Hello. As I'm practicing with making videos and working with my technology, I figured I would use the opportunity to practice to go through an integration video. I mentioned when I talked to you during the soft opening that I wanted you to look at just your basic integral rules and techniques that you had learned back in chapter 4 and then a few special ones in chapter 5. And I figured why not just to make a video, because sometimes again it's easier to listen to me talk about it than to just flip through your notebook. So I have some slides here just kind of talking you through the progression of what we've learned. So the first thing we did with integration is we just looked at a basic power rule. The basic power rule was the idea that as long as you had x to any power, it can be positive, negative fraction, the way we integrated is just power 1 greater divided by that power. So for this first one is a really simple example to start. Power 1 greater would be the 7th power over 7. Power 1 greater for the next term would be the 4th power over 4. Power 1 greater. This is going to be 2x to the second over 2. If you want to write that, you can, or just realize it's just x squared. And then for a constant, it's that constant times x. And then for all of our integrals, when we talk about our indeterminate form, we're going to put a plus c. It's called an indefinite integral because we don't know what c is. If we can have a value, we also call it a general solution because, again, it's very generic. If we have a value for x and y, if we have a point, we can plug that in and find that and get what's called a particular solution. So trying to bring back some of that terminology from last year. If we have boundaries on our integral, that's a definite integral when we actually find a numeric value. But we're really going to focus, especially in these first few days and first few lessons, on just generic solutions, general solutions, indefinite integrals, and getting kind of our memory back as far as what we did before with integration. Then we talked a lot about how oftentimes you have to rewrite integrals in order to do them because we don't have a lot of integration rules. We don't have product rules or quotient rules. So if we have something in the bottom, like this one that you're looking at, you have to rewrite it with a negative exponent. So we did a lot of rewriting with integration. Algebra was a kind of our friend. So power 1 greater divided by that power. Get in the habit of moving negative exponents to the bottom and then getting your answer, and then again that integration constant, that plus c at the end. If it had a radical notation, we had to rewrite it because, again, we have no other way to go about it other than getting it in terms of a power rule. So this is the power over root. So power 1 greater would be the 8/3 power divided by that power. So 8/3 divided by that power is going to be 3/8, x to the 8/3 plus c. So that's what we did in the very first day of chapter 4, is just looked at basic rules and basic rewriting. Then we talked about trig. I'm not going to go through and do a bunch of trig for you, but I figured let's put it in one place. These were, I often refer to as the big 6. These are the main 6 trig integrals that you should be very fluent with. They all stem from our derivative rules that we had learned earlier last year. There are some other kind of higher level trig ones that we got into later in chapter 5, but these are the ones that you should be very, very comfortable with. As we continued in the chapter, we eventually used these again when it came to u sub with trig. So knowing that when you have a secant squared that you're going to integrate and get tangent, or knowing that a secant tangent integrates to secant, is something that was used throughout chapter 4. Then we got to the second half of chapter 4 and we got to u sub, and we talked about lots of different u sub ones. We talked about ones that were absolutely perfect, which doesn't happen very often. We talked about ones that had an adjustment, which was very common. We talked about ones that were trig based. So just to kind of go back to the beginning stages of that, if you're looking at something like this first one on the upper left, your u is going to be the piece that has something done to it. Your du is going to be the derivative of that. And then what we had to do to determine adjustment is look at our du and look at our original integral and see, well, what's there, what's not. We don't have the 3, so we're going to divide both sides by 3. So we say that it's a 1/3 adjustment. And then our next step is to figure out what's being done to u. Is it being squared, cubed, square rooted? In this case, it's a negative power because it's in the bottom. It's a u to the negative 4. So power 1 greater is u to the negative 3 over negative 3. You don't want to leave negative exponents, so you're going to move back to the bottom. So you're going to get negative 1/9, and then you're going to have 5 plus x cubed plus c all on the bottom. For trig was more challenging because the choice of u could be the angle or it could be an actual trig function. So I want to show you one of both. For this one, since you only have sine, the u has to be the angle. Derivative of that angle is 4x cubed, and that has to be in your original integral or some version. We don't have the 4, so we're going to divide both sides by 4. And then when we say what's being done to it, well, it's being signed, which again, we made up verbs a lot last year and will continue to do so. The integral of sine is one of the 6 that you should know. It's negative cosine. So you get a negative 1/4 cosine of x to the 4th plus c. You don't have to put the x to the 4th in parentheses. I just kind of wanted to have it stand out. For this one, now we have 2 different trig functions, and tangent secant to different powers is not going to be a known integral. So we have to let u be one of our trig functions. In this case, we're going to let u be tangent because the derivative of tangent is secant squared, and you have that. So when you work with tangents and secants, they tend to go together. That's what you're looking for. So when we say what's being done to it, if you let u be a trig function, it has to be a power rule integration. So what's being done to tangent is it's being taken to the 4th. So you would get u to the 5th over 5, which is tangent to the 5th over 5 plus c. And that really took us to the end of chapter 4. Then we got into chapter 5 and we started just looking at some special cases. Chapter 5 was the misfit functions chapter when we just started doing a little bit of everything. We worked with ease, we worked with natural logs, we worked with inverse trig, we worked with inverse functions. So when you're dealing with natural log, oftentimes you'll have a problem that'll just start out as a u sub. So like this first one, your u is x squared plus 5. Your du then is 2x. You don't have the 2, so you have to divide both sides by 2. So you have a 1/2 adjustment. But now this is a situation where you're not going to do a power rule because right now this x squared plus 5 is just to the first power in the bottom. There's no such thing as a u to the negative 1. So this is our special case. This is du over u, which is exactly how we get a natural log because that's the derivative of natural log is du over u. So if you have an integral with that, you get a natural log. The 1/2 stays out front. So we have the natural log of x squared plus 5 plus c. The reason absolute value bars are used is because you can't take the natural log of something negative. So putting that just ensures that you'll never get a negative. Really doesn't come into play until you start putting numbers in. If you have a situation where natural log is part of your integral, it has to be your u. There is no exception to this. It's actually going to show up this week in another format, but the rule is the same. Your u has to be the natural log. The derivative of the natural log of x is 1 over x, which is exactly what you have. So what's being done to this? It's being taken to the 4th power. This is just a power rule. So you get u to the 5th over 5, which is natural log of x to the 5th. You can put the 5 outside parentheses, or you can put it between the n and the x, plus c. We did this in section 5.2, if you're trying to look in your notes and kind of follow along. Then we did ease. We spent 5.4 and I think just 5.4, and then we kind of went into other bases in 5.5, working with ease. Ease is one of the easiest derivatives. It's basically just itself times the derivative of the power. With u sub, oftentimes the most basic one, your u is your power, your exponent, or you could say x to the 1/2 here. Derivative of that is power out front, power 1 less. So you get 1 over 2x to the 1/2. That's a horrible half. Sorry about that. You have the x to the 1/2 in the bottom right there, but you don't have the 2, so it's actually a times 2 adjustment. And now your format here, what's being done to it is just an e to the u. The integral of e to the u is e to the u, just like the derivative is itself. So you get 2 e to the u square root of x, or x to the 1/2, plus c. We also had situations where e was part of your integral. It wasn't necessarily an e to the u, but there was an e that kind of took a different location or a different placement. In one like this one, your u is going to be the entire denominator. Derivative is 2e to the 2x. Derivative of an e is itself times the derivative of the power. You don't need the 2, so we're going to have a 1/2 adjustment. And this is going to be in some form, either in this case, it's a du over u. You might even see ones that are like power rules, like u to the 1/2, something like that. This is just a du over u. So we get 1/2 natural log of 1 plus e to the 2x plus c. And finally, the last thing that we did with integration, and there were some other things that I've skipped over, but I was trying to hit the big ones. The last integration form that we learned was how do we integrate something that actually ends up in an inverse trig format. So looking at something like, I can't do a u sub, it's not something that's going to have some sort of algebra, and having a backup plan. If you look at this denominator, the tempting thing is to let u be the entire thing under the radical. But the problem with that is the derivative of 9 minus x squared has an x in it. It's negative 2x, and that's not there. So I always recommend thinking u sub first, but then think, well, if that didn't work, what are my backup plans? We had 3 inverse trig integrals: arcsine, arctangent, and arcsecant. Arcsecant, honestly, I'm probably never going to talk about because it's so rare. Arcsine will show up occasionally. Arctangent is actually the most common. So with these, you're in the form where you're going to have your u, your du, and your a value. So your u is what was squared to get the variable squared. So we had an x because that was squared to get x squared. Derivative is just dx, so no adjustment. Your a is the number that was squared to get this 9 here. So your a is 3. The formula for arcsine, it actually has nothing in front of it. It's the only inverse trig function that has nothing in front of it, is just the arcsine of the u over the a. So this would be an arcsine or inverse sine of x over 3. Tangent's probably the easiest to recognize because it looks different than the other ones. Tangent has no square root and it has an addition, so it's a very different look than the other two inverse trig. You still have the same setup. Oh wait, I forgot the 5, sorry. I'm sure you're watching this going, she forgot about the 5. There should be a 5 here. There you go. Your u again is x, your du is dx, and your a is going to be 4 because that's what was squared to get 16. Now, what we have with arctangent, and that's what this is you always have a 1 over a in front of your arctangent. You're also going to have the 7. I'm not going to forget about this time. So you're going to have a 7 over 4 as your coefficient, and then you're going to have your arctangent of x over 4 plus c. So that gives you just an idea of all the different integral rules. Obviously, we did many levels, many examples, but I think if you just want a refresher, hopefully this video provides that refresher for you.